Our next topic in Chapter 2 is the topic of acids and bases. Acids are defined as substances that donate hydrogen ions, whereas bases are substances that accept hydrogen ions. So it's all about the concentration of hydrogen ions in solution. As you're well aware, the acidity of a solution has a dramatic impact on the interaction of that solution with biological tissues. And so you want to be careful about coming into contact with something that's too acidic or too basic because of damage to your skin, for instance. So let's talk about the pH scale for just a moment. The pH scale is used to determine how acidic or how basic a substance is. As you likely are aware, the scale ranges from 0 to 14. 7 is neutral. Anything above 7 is a base on the scale, that is, as we see over here to the right-hand side of our diagram. Anything below 7 is an acid. And so there's several things we want to keep in mind as we look at the pH scale here to the right of our slide. So one is this, that the pH scale is a measurement of the number of hydrogen ions in solution. Remember, an acid gives off hydrogen ions, a base accepts hydrogen ions. And so interestingly, what we see is that the pH is the inverse log of the hydrogen ions that are found in solution. So this means that if we focus on the right-hand side of our diagram here, as we increase the number of hydrogen ions, the pH goes down. So again, more hydrogen ions means a lower pH and a more acidic solution. As we decrease the number of hydrogen ions, then the pH goes up. And so that's because pH is an inverse log of the hydrogen ions in solution. In this particular class, you may be glad to know that you will not have to calculate pH, but you do need to know the relationship between the number of hydrogen ions in the pH and the acidity of a solution. And so a low pH means a lot of hydrogen ions and a very acidic solution. We see, for instance, coffee comes in at a pH of 5. Coke is even a pH of 4 or 3 or so. And then a battery acid is a pH closing in on between 1 and 0 there. And so you can come in contact, of course, with coffee or Coke, but battery acid will burn you severely. As we move up to the top of our slide, we see baking soda is a pH of 9, ammonia is a pH of 11, and drain cleaner, which would also cause burns to your skin, is a pH of 13 or so. So most biological solutions are around a pH of 7. Your blood remains between a pH of 7.35 and 7.45, always in that very constant region there. There are parts of your body that have a lower pH. For instance, the contents of your stomach has a pH in the even 3 to perhaps 2 region. But most of the solutions found in your body are in a fairly neutral pH range.